Right. In last class, we were discussing about the equations of motion based on this object under constant acceleration. Today, we are go ahead with the questions based on that one. Okay. Let's come up with the first question today. A particle is moving along a straight line from A to B. A to B, so A is the initial point and B would be the final point. With a constant acceleration, therefore, we can have this acceleration is 5. That acceleration is 5. Now we have this information A equals to 5. Okay. Then the velocity of the particle is at A is 3. That means starting from A, therefore obviously this U become 3. Right. The direction to OB. So it's moving from A to B. The velocity of the particle B is 18. Now you know that A is the initial point and B is the final point. Therefore final velocity would be 18. Right. Okay. Then the question is find the distance from A to B. So simply what you need to find is they are referring to find the distance. So it's a relationship between we know the value for A, we know the value for U, we know the value for V, we need to find the value for S. So in this case, simply the relationship joining UVA and S is the equations of motion. What we know is S equals to UT plus half a t squared. You cannot use this for the reason because it's not involvement with t. Other one is v equals to u plus at. Here also not related with t, so can't do it. Other one is sc equals to u plus v over 2 into t. Over here also t is involved with t. So the last formula we can apply v squared equals to u squared plus 2as. When you are marking this, directly you have to mark the direction. That is quite important. Right. So you can simply apply this formula over here. Then it's turn up to u is how much? 3 squared plus 2a. A is 5. It's already here. It's already here and s. Right. So I will use the annotation. That's kind of easier for me to show. Screen then you have to find s. So you can write 18 squared is 324. 3 squared is 9 equals to 2 into 5 into s is 10s. Then you can bring this 9 to this side. Then what happened here? 324 minus 9 equals to 10s. This is 4. Then you can say s is equals to 324 minus 9 is 315 divided by 10. It's turned up to 31.5. It's remember you need to put the units. That's quite important because all of these facts are given in meters per second and meters per square second. The final answer should be 31.5. That is a way of obtaining the answer for this question. Right. Okay. That is a way of doing it. Right. Let's go to the next question. Yes. Now this is a little bit of an important question over here. A particle is moving. A particle is moving in the straight horizontal line with a constant deceleration. Then we can mark a is minus 4. Right. Okay. At time t equals to 0, that means this is the initial condition. The particle passes to point O with velocity of 3. Therefore, you can say u equals to 13. Right. The traveling towards a point A where OA is 20. Towards point A, there is a final point. Therefore, you can simply write S equals to 20. This is pretty simple. Find the times where the particle passes through A. Now we have a doubt with it. There's a small issue with that. We will do it. Needed to find the value for times where it passes through A. Right. Now let's work out this question with it. Right. Simply I will just use this space over here. I can apply now relationship between UVA, U, USA and T. So simply you can apply. I will show you the working where I have done over here. Now you can say, look at this. S is how much? 20. S is 20. It's here. Look at this 20. UT. U is 13. T is the one we need to find it. Plus half A. Why it's minus 4? Because they specifically mention it's a deceleration. Minus 4 T squared. Then 20 is equals to, so it should be 20 here. 20 is equals to 13T minus 4 into half is minus 2 T squared. Then to solve this, bring this 20 to this side. bring this 20 to this side, it's turn up to then 2t square, 2t, sorry, it's easy like this, but just, it's rather than that, doing this is quite easy. Rather than that, bringing this, yeah, it's 20 is here, sorry, 20 is here. Then I will bring all these two terms to this side. It's quite easier for me. Then it will form a positive quadratic equation. Look at this. So if you bring this minus 2t to other side, what happened? Plus 2t squared. Minus 13 to other side, plus, sorry, minus 13, not minus, plus 13. 2t squared plus, sorry, minus 13t. Again, I made the same mistake. Sorry. 2t squared minus 13t. The 20 is already there. So it should be 20 equals to 0. Then what you can get here is that either you can factorize it or you can use the formula itself. So if you feel like factorizing is hard, you can use the formula. T equals to minus 13 plus or minus b squared minus 13 squared minus 4. A is 2, C is 20 divided by 2a. 2 into 2. With this, you get the answer t equals to 5 over 2 and t equals to 4. Now you get 2t answers. 2t answers. That is what you mean to do it. It's just like this. This is the situation. Why do you get this? 2t answers. One answer is 2.5 and other answer is t equals to 4. What you have done over here is just like this. Like we will get some kind of a toy car. I'll get a small. This is the situation where we can see. Right. There's a toy car over here. Right. It is joined to a rubber band over here. It's joined to a rubber band over here. Right. Then at the beginning, this toy car, what happened? It's you give it like kind of a tap and you gave a velocity of how much? 13 meters per second. This kind of situation only we are talking about. Therefore, now the toy car starts to move. The toy car starts to move like this. I think you can see my arrow. It's moving, but because of this rubber band, what happened? It's moving under deceleration. Remember, for a rubber band, it's not continuous, but I'm just to show you what is the basic understanding only. But for a rubber band, it's not, you don't feel a constant acceleration. We are learning if it is in mechanics too as well. Now it's running under deceleration, but anyway. Deceleration and deceleration, slowing and slowing down. At t equals to 2.5, it reached this point. And this is point A, but still it can move further. And it come up to the maximum deceleration, maximum displacement. Why? Because it's slowing down and slowing down and slowing down, slowing, still. And at one point, what happens? It stops. Here it stops. Since the rubber band is stretched, what happened to it now? Aflal? Since it...
yes, sir.
Yeah, now you can say that this is the rubber band is there. Now rubber band is stretching with this vehicle. It's going up.
It pulls back the vehicle.
It's pulled back the vehicle. As a result, what happened here? From here, it stops. And after that, what you can see, it's going back. Is that clear, Pate, what is happening over here?
Yes, sir.
Yes. Adril, is that fine with you, Pate? And Hamdi, how about you, Pate?
Okay.
Yeah, that's great. Now, this is the second time. Again, it's coming back. At the second time is the one where we represent it as how much? 4. That is why you get 2 answers over here. That is the fact we need to understand with this. Then the next question is the value of t when the particle returns to O. This is O. So we had the starting point is O. Now, when you return to the original position, what you can see, I'll just read this part of it. It's there in the now. When you return to the original, what happened here? The displacement is how much? Displacement becomes 0. Displacement becomes 0. With this, you can say U is how much now? Displacement is 0. U is 13. A is minus 4. We need to find the value for t. Again, you can apply the formula SC equals to UT plus half AT squared. Then SC is 0, 13t minus 2t squared. Now, out of these two, you can take t out and you can write 13 minus 2t. This is the answer with that. Then you can see this is 0. If a product of, if a factorized form is equals to 0, we know that either this should be 0 or 13 minus 2t should be equals to 0. So you can write t equals to 0 or, but you can say 13 minus 2t equals to 0. How do you write it, Pate? Can you remember in quadratic equation, we got this kind of situation?
Yes, sir.
X plus 3 equals to 0. Now, how do you write it? Then you can write either x minus 2 equals to 0 or x plus 3 is equals to 0. Same kind of condition. With that, you can say t equals to 0 and t equals to 13 over 2, right? Okay, this is quite practical. Okay, 13 over 2. How does this 0 came, Pate? Because we know that at the beginning even, what is the displacement? Displacement was 0. At the beginning itself, the particle was, it was displacement is 0. So that is the time you obtain over here as the one answer as 0, because you know that at the beginning itself, it was at a displacement of 0, because start from the initial point. That's a fact we need to understand with that. Okay, right. So what would be the, what kind of a motion is this, Pute? Then if it comes like this, if it is fixed over here, it goes like this and it returns, and over here it has a velocity. Because of that, it goes this way. That is that kind of a motion you can expect from this kind of motion. So that is it. You can go with this. That's how it comes with it. Right. Okay. Right. Now that is how you need to do this kind of a question. Right. Okay. Okay, this one also is quite similar to that kind, that previous question today. A particle P is moving on the x-axis with a constant deceleration of 2.5. Therefore, we know that A is minus 2.5. At time t equals to 0, particle passes to origin O, moving the positive direction x with a velocity of 15. U is equals to 15. Find the time between the instant where P first passes to origin O and instant when it returns to O. Right. Uh, the time instant particle passes to origin O, move with the positive direction of velocity of P. Find the time between the instant where P passes to O and when it returns to O. That means we need to find the time where this is starting from here and it goes over here to the maximum displacement. It can return back the same like previous. We need to find the value for t. So you can say that obviously same fact as what we did in the part 2 in the previous question. A is minus 2.5. A is minus 2.5. SC is A is minus 2.5, U is 15, SC 0, we need to find the value for T. That's a problem where we come across. So if you apply SC equals to UT plus half AT squared, you get the answer 15T plus half into U is minus 2. A is minus 2.5 T squared. With that you get a quadratic equation, and again you get similar condition as the previous thing. That is, what are the two solutions? But the two solutions become t equals to 0, that is the initial point itself, and again it travels at where when t equals to 12. Right, you can adjust this kind of situation. At t equals to 0, it's here. When t equals to 12 is here. So after that, what happened here? This should travel this way. Okay, that's a fact we need to understand with this question. Let's see what the part B question they are referring to. The total distance traveled by during this time. Right. Okay, we'll come up with this. We need to find the total distance. Total distance means this is what? Right. That means it travels from here to here, again here to here. Now you can see these two lengths are similar. The distance traveled from here to here, if you twice it, that should be the answer for that. Right. Then over here, what is the conditions we know? U equals to 15. Here the A is minus 2.5. Here the what is the value of Pute? At the maximum displacement, V is equal
0.
to 0. That's great. So you can apply, it's a relationship. We can find the value for S from here to here. I'm referring to the distance from here to here itself. Then we can apply V squared equals to U squared plus 2S. U E squared is 0 here. U squared is 15 squared. 2A is minus 2.5. Don't forget about this point. Minus 2.5 with S. So if you put it, you get 45 with it. Then they are referring to distance. Distance means distance from here to here, then back to here. Then what happened with it? Obviously, it's 45 into what? into 2. 45 into 2 would be the total distance, that is 90 meters. It will travel it has a displacement of 45. It has a displacement of 45 and distance of how much? Pate? Distance of 90. That is
Sir,
what we need to understand with this. Yes, Aflal, what is it?
displacement of 0.
No, sorry. If I am referring to this point, Pate. If I
Okay.
refer to this point, the displacement is 25. Yeah, so you can say displacement of OA is 45. Total displacement is 0. Total distance is how much? Total distance is 90. Displacement from O to A is 45. Total displacement is 0 and total distance is 90. Those are the facts to be understand when you are working out with this kind of a question. Hope you can understand how we did it. Right. Okay. Yes. So you can note down those things later. Okay. Now let's start with the first question. It's in the exercise, right? Exercise 2E. A particle moving with straight line with constant acceleration of 2.5. Therefore, I'm referring to the first question. Acceleration is 2.5. It passes point A with velocity of starting A from moving from A to B. Therefore, U equals to 3. 3 and AB is 8. SC is 8. Find the velocity of the particle passes to B. Honey, what is the value for B? It's a factor to understand. So simply you can apply this side. It's a relationship with UV, A and S. V squared D equals to U squared plus 2AS. So V squared is one we need it. U squared is 3 squared plus 2 into acceleration is 8. It's not deceleration, it's acceleration. SC, sorry, it's 3, sorry, I made a mistake. It's 2.5. Distance is the one, it's 8. Into acceleration is 2.5 into 8. So it's turn up to V squared is equals to 49. If you simplify this bit of it, you get V equals to plus or minus 7 meters per second. So obviously what you can see here is it should be plus value. So you can write V equals to plus 7 meters per second because it's still with an acceleration, still moving to this side. Right. That's a fact we need to understand with this kind of a question. That's a way of answering the first question today. Right. Okay. Right. Then if you come up to part question number 2 today. A car is accelerating at a constant rate along a straight horizontal road, traveling at 8 meters per second. It passes the post, and 6 seconds later, it passes the sign. Okay, that's great. So that means it's moving somewhere like this, and it comes back this. So traveling at 8. So you can say initially U is this side 8. And after 6 seconds later, T is 6. Then, okay, car station concentration this much, traveling at 8 meters per second, passes a lamp post, and 6 seconds later, it passes a sign. Okay, 6 seconds later, it passes another sign. Okay, the distance between lamp post and the sign is 60 meters. SC is 60. Find the acceleration of the car. Our reference is what is the acceleration. So it's a relationship between S, U, A, and T today. So simply we can apply toward this side, S equals to UT plus half AT squared. So you can write S is 60, U is 8T plus half into, sorry, T is 6, sorry, I made a mistake. T is 6, 8 into 6 plus half into A into time is 6 squared. So it's turned up to 60 equals to 48 plus 18A. So with this, is it moving under traveling this much? Car is accelerated, concentrate on this much, traveling at 8, passes a lamppost 6 seconds after it comes. The distance between lamppost and the sign is 60. Okay, yeah, that's it. So you can say 18a equals to 60 minus 48, that is 12. Therefore, a equals to 12 divided by 18. Then a become how much?
2 over 3.
0.2 over 3, 0.67 meters per square second would be the final answer for this question. That is a way of getting the answer for this question. Okay. It's not written in back. I just typed two different point over here. That's all. When you come up to question number 3, Pute. A cyclist traveling at a 12 meters per second applies brake. That while you are moving with 12 only, you apply brakes. That means you become how much? 12. That's a fact we need to understand with this. Come up to rest means u is v is equals to 0. Traveling 36 meters. 36 meters, it passes, sorry. Assuming that the brake causes the constant cycle decelerate uniformly. What do you call decelerate uniformly? It is having a constant deceleration. If the deceleration varies with time, obviously you cannot apply these equations of motion. We define the deceleration. So we just work out with A. So simply apply this side, v squared equals to u squared plus 2a s. So the v squared is 0 squared is equals to 12 squared plus 2 into a is the one we need to find it. S is 36. It's done up to then 144 plus 72a. Then 72a equals to minus 144. Therefore, a become minus 2 meters per second. That implies your deceleration of 2 meters per square second. Sorry, square second. That is the answer for question number 3, right? Okay. So from this negative mark also, it's kind of like we can get kind of evidence that yes, our answer is quite fine, because obviously it's a deceleration, means you should get a negative answer for acceleration. So we have a little bit of evidence to say yes, our answer is quite fine, right? Yes. Now let's come up to this question for the fourth one. Yes. Fourth one I'm referring to, right? A train is moving at a straight horizontal track with a constant acceleration. The train passes the signpost of 54 kilometers per hour and second sign at the velocity of 72 kilometers per hour. The distance between signs are 500 meters. Find in meters per second, meters per square second, the acceleration. Therefore, we need to convert this 54 kilometers per hour into meters per second. How to do it, Pute? Multiply by 1000 and divided by
Divided by 3600.
600. Yeah. What is this answer? I think 15. It's 15. So it should be
15.
15 meters per second. 72 kilometers per hour.
72 must be 20.
Yeah. It's turn up to 20 meters per second. So you know that the u is now, sorry, u is 15.
50.
V is 20. Distance is S is 500. And we need to find the acceleration A. It's a problem we come across. So we can apply this side. Sorry, we can apply, it's a relationship between V squared equals to U squared.
V square.
20 squared is equals to 15 squared plus 2 into A into S. S is 500. So it's turn up to this is 400 minus 225 with these 2 equals to 1000 A. Therefore, A equals to 175 divided by 1000. A is 0.175 meters per second. That's square second. That would be the answer for A. That's a way of doing this kind of a question. Yeah, that's it. Right. Then let's come up to question number 5. If you refer with question number 5, a particle moves along a straight line with constant acceleration from point A to point B. So this is the initial point and this is a final point where AB is 48. So you can write SC equals to 48. At A, the particle has a velocity of 4. U is 4 and B has a velocity of 16. B equals to 16. Find the acceleration. So you can find A. Okay, so you can apply this side. V squared D equals to U squared plus 2AS. It's 16 squared equals to 4 squared plus 2 into A into S. S is 48. With this you can write 256 minus 16 is equals to 96A. With this you get the answer A equals to 256 minus 16 is 240 divided by 96, 240.
2.5.
A is 2.5 meters per square second. Hopefully that is fine. Let's work out and see.
Yes, sir. 2.5.
Yeah, 2.5. That's right. Okay. Then the time the particle moves from A to B, we need to find the value for t. So simply you can apply V equals to U plus 18 because we know the acceleration. V is 16, U is 4, acceleration is 2.5 into t. So with this t become 16 minus
4.8.
4 is 12 divided by 2. So how much? 4.8
8.
seconds. Sorry. Yeah. 4.8 seconds would be the answer for this question today. That's a way of answering the question number 5 today. Yes. Now let's come up to question number 6 today. A particle moves along a straight road with a constant acceleration of 3. 3. A particle moves 38 meters, means S is 38 in 4 seconds per day. Find the initial speed of the particle. We are referring to what is U per day. So simply we can apply S equals to ut plus half at squared. S is 38, U into time is 4 plus half into 3 into 4 squared. So it's turned up to 38 equals to 4u. This is 16, 48, 24. If you brought it to other side is 14 equals to 4u. Therefore, u become 3.5 meters per second. Okay. Then final speed, we can apply simply p equals to u plus 80 because we know these facts. U is 3.5. A is, we already know it's 3. Time is, it happens for 4 seconds. It's turned up to 3.5 plus 12 is 15.5 meters per second would be the answer for this question. And we are referring to the question number 6. That is the part A and this is part B answer. This is part B and this is part A answer. That's how you need to obtain the answer for these questions. Right. That's why it comes.
Sir,
Yes, Pute. Yeah,
sir,
what's
when
it?
is the term test?
Right. Okay. A driver of a car is traveling at 18 meters per second. That means U is 18. U is 18. Along a straight road with when it shows an obstacle, ahead she applies brakes and brake causes the car to slow down to rest. To rest. That is V is 0. Rest means it's 0. With a constant deceleration of 3. Therefore, A is minus 3. You have to remember that when the term comes, it come up to negative. Right. The distance traveled. And the first question is distance traveled. Yes. So simply we can apply this side. P squared D equals to U squared plus 2AS. So that is 0 squared is equals to 18 squared plus 2 into A is minus 3 into S. Therefore, S become 18 squared divided by 6. You can obtain the answer very easily. So
54.
yeah, divided by 3 is 54. Divided by 6. Okay, 54. It should be 54 meters. After moving for 54 meters, it stopped. That means after when you see an obstacle, if the obstacle is more than 54 only, your vehicle is safe. Other than that, what happens? But definitely you will hit with the obstacle. So therefore, you need to apply properly the brake to make it. If you want to stop the vehicle before the obstacle. Then the time taken the driver to decelerate from 18 to rest per day. So I need to find value for V. V equals to U plus 80. That's for part B answer I'm referring to. V is 0, U is 18, A is minus 3 into T. Therefore, T equals to 6 seconds. After 6 seconds, the vehicle stops for moving after 54 meters. These are the practical aspects of having this question. Yeah. Then let's come up to question number 8. When you come up with the question number 8, it's a stone is sliding across a frozen lake in the horizontal lane. The initial speed of the hot stone is 12. The U is 12. The friction between the stone and the ice cubes of stone slow down to the constant rate of 8. That is, A is minus 0.8 meters per square second. Find the distance traveled with the stone before it come up to rest. Come up to rest means V equals to 0 and find the distance traveled. So this side you can apply V squared D equals to U squared plus 2AS. So 0 squared is equals U squared is 12 squared plus 2 into minus 0.8 into S. So S become 144 divided by 1.6. So after making this is 1.6 with that, you can get this answer. So this
90.
90, right? Okay. It's 90 meters per day. 90 meters, right? Okay. Then the speed of the stone at the instant where it's travel half of the distance. Half of the distance, right? So you know that for this case, U equals to 12. I'm referring to part B. And A is minus 0.8, half the distance. That is, S become 45 meters. But we need to find the value for what is V. So simply again, we can apply this side. V squared D equals to U squared plus 2AS. The V squared is the one we need to find it. U squared is 12 squared plus 2A is minus 0.8. S is 45. With this, you get the answer V squared equals to 144 minus is 18. 18. With this, you get the answer V equals to square root of
70.
yeah 17. No.
Square root on 8.5.
A is U square for sorry with the initial speed is 12 squared. 2A is 45. Put it by 2 into 0.8 into 45. It's 72. 2 into 0.8. This is 72, not 18. This should put in 2 into 0.8.
No, sir. Final answer is 72 in there.
72.
Root 72 must only come.
Yeah, root 72 is the answer. That's great. Yes. The square root of 72 is 6 root 2. 6 root 2 is 8.48. Isn't it? 49 meters per second. That's the answer what you need to get from here. Okay, that's a way of getting this answer for this question. Right, let's come to this ninth question. Right, ninth one. If you refer with this, the particle is moving along a straight line with OA with a constant acceleration of 2.5. A is 2.5. At time t equals to 0, the particle passes to O with speed of 8. UV equals to 8. It's moving in a direction of OA where the distance OA is 40. S is 40. Find the time taken for the particle to move from O to A. Particle to move from O to A. And what is time t? So this is also pretty simple. You can apply this side. SC equals to UT plus half 80 squared. S is 40 equals to U is 8 times of T plus half into 2.5 times of T squared. 1.25 T squared plus 8T minus 40 equals to 0. So with this, you get the answers for T. You can use the quadratic equation for this. Yeah, let's see. 1.25.
3.3 seconds.
Yes. Yeah. One answer is 3.3 ne. One answer is 3.3. Other answer is minus
minus
9.
9.7.
Minus 9.7. That means obviously time cannot be negative. Therefore, time is how much? 3.3 seconds. That's what to understand. Then the speed of the particle A given that. Okay. Yeah, totally we can apply V equals to U plus 80. U plus 80. U is 8. A is 2.5 into time is 3.3. 8 plus 2.5 into 3.3. It's roughly 16.25. 25 meters per second would be the final answer for this question.